Hello everyone, in this video let's discuss about the BFS and DFS search algorithms in data structures. If you are new to our channel, please subscribe for more engineering related topics. Now, what is BFS? BFS is the breadth first search algorithm, and this breadth first search algorithm will be following the queue data structure. It will be following the queue data structure and FIFO principle. What is FIFO principle? FIFO principle can also be called as the first in first out principle. First in first out. That is, since we are using the queue data structure, which of the node will be coming into the queue first, they will be kicked off from the queue first. That is, who will come first, they will be get out from that queue first, like that. Now let's solve this given tree or the graph. So we will be using the queue data structure. So let's draw a queue, and after removing from the queue we will be writing in the result. Now we must consider a node as a source node. So let me consider 0th node as a source node. If I consider 0th node, first I must insert 0 to the queue, and then from 0 I have direct connection. That is, from 0 I can go to 1 and I can go to 3. So 1 and 3. Now, so I am moving from 0 to 1 and 3. So this node is over. So I will be taking 0 down. That is, who came first, they are kicked out from the queue first. Next, 1, because 1 came first. You can write 3 also. So this BFS will be having different answer. If you take 1 here, it will be different answer. If you consider 3 first, it will be different answer. So like that. So 1 will be here. From 1 you can go to 3. 3 is already in my queue. So 0 you can't go because you came from there only. Now you can go to 2. Next you can go to 5. Next you can go to 6. Now, so who is the first one to come? That is 3. So I will be taking 3. So 1 is over. Now 3. From 3 I can go to 2, I can go to 4. 2 is already in my queue. I will be adding 4 to the queue. Now 3 is over. Next who came first? 2. So 2 will be considered. From 2 I can go to 5. 5 is already in my queue. And 2 I can go to 4. So 4 is already in my queue. So I can write 2 here. Next 5. So from 5 I can't go to anywhere because all are traversed. So the directly connected nodes for the 5 is already traversed. Now I will write 5 here. Next it will be 6. So from 6 I can go to 1 and I can go to 4. So 1 is already traversed and 4 is already in my queue. So I will write 6 directly. Next it will be 4 because only one node is left. So it will be written directly. So if you see, who came first, they are written in the result first. That is, who came first, they are kicked out from the queue and written in the result first. Now, for the same tree or the same graph, let's draw the DFS. So what is DFS? DFS means depth first search. Depth first search. So what it will do? It will go on searching for the nodes in the downside, that is as depth as possible. If it not complete there, then it will backtrack. So DFS will be having backtracking in that one. Backtracking. Now this DFS or the depth first search algorithm will be following the stack data structure. Stack data structure. Now let's solve the same graph. So this is my stack, and which will be removed will be written here in the result. Now if I consider the same node, that is 0 as the source node, so 0 will be inserted. From 0 I can go to 1 or I can go to 3. From 0 I can go to 1 or I can go to 3. Now at the result you will be writing 0 because you are coming from 0. Now you can go to 1 or you can go to 3. Since it is the depth first search algorithm, you will be using the third node. So write the result 3 in the node. So 0, 1, 3 are already in my queue. Sorry, 0, 0, 1, 3 are all in my stack. So I will be writing as it is. Then from using 3, I can go to 1. So 1 is already in my queue. I can go to 2. Next I can go to 4. Now among 2, 4 and 1, I can't go with 1 because it is already in my queue. 2 and 4. If you see, who is going deep? 4 is going deep. So I will be selecting 4. Next. So write as it is. 2, 3. 0, 1, 3, 2, 4. So it is not 3, it is 4. Now from 4 you can go to 6. From 4 only one possibility is you can go to 6 because 2 is already in my stack. So you will be writing 6. Now when the process stops means when the stack is empty. My stack is not empty because the fifth node is not traversed till now. What I must do? From 6 I can't go to fifth node. So what I will be doing? I will be backtracking. From 6 I will go backtrack to 4. So 6 will be popped out from my stack. So here 6 will be written. Next from 4 I can go to 2 or I can go to 3. So I will be popping out 4 and I will be going to 2. And I will pop out 2 and I will be going to 5. So I can write 5 in the place of 2. Now I have written the value in the stack. So I can write 5 as in the result. Now if you see, all the elements are, now all the nodes are traversed. My ultimate goal is to empty the stack. So backtrack. So from 5 I will come again to 2. So 2 is already cancelled. Since I come back from 5, 5 will also be cancelled. Next from 2 I will be going back to 3. So 3 will be cancelled. From 3 I will be going back to 1. 1 will be cancelled. And from 1 I will be going back to the source node. Now my stack is empty. Now my stack is empty. When you make the stack as empty, the problem will be stopped and the result is 1 and the result is 0, 1, 3, 2, 4, 6, 5. So this can also vary because more possibilities are there in DFS and BFS answers. So hope you understood the concept of the DFS and BFS. If you liked the video, please comment below and please subscribe and support us so that we can make more engineering related topics videos. Thank you.